Hello and welcome student to this section, section 9.9, which will be application of the marginal derivative. We have seen in many of the examples before, we have the marginal revenue, marginal cost, marginal profit, and it has a meaning. We discuss some of this meaning. What we will do in this section, we will go over like a revision to what we did in the same context. So let me start first of all with reminding you about the formula for the revenue. Suppose there is a company that is selling product. Suppose we have X units that we sell. How do we find the revenue? Of course, the revenue will be the number of quantity sold times the price for each unit. And this price is not fixed. It goes through the demand law. So the demand law will give me the price, and then I will have my revenue, which will be X times P of X. Remember, the demand law says that when the price goes up, the demand or the quantity to be sold will be less and less. So that's the rule that we have. Or we can think about it in the opposite way. If there are so many items in the market, the price has to go down because it means the market is saturated. Now, the marginal revenue, usually we write it MR bar, it's just the derivative. Remember, marginal means the derivative. And what does it mean? The marginal revenue is an approximation or estimation of the revenue gained from the sale of one additional unit. For example, if the MR equal 30 at X equal to 10, I'm expecting when I go to X equal to 11, my revenue will go up by $30. So it is kind of a prediction, it's estimation of what will happen if we sell one more item, how the revenue will go up and how much it will go up, or if the revenue will go down, if it's with negative, and how much it goes down. Let's see this in one of the example. Example number 1. Suppose the total revenue is given by this formula. Part A, we need to find MR bar. What does it mean, MR bar? So A, MR bar, it's just the derivative. So we find the derivative of this function, which will be 44 minus x squared, the derivative is 2x, and we multiply 2 by 0.05, so we get 0.1 x. And that's the marginal revenue. Part B, it says that find the marginal revenue at x equal to 3. So we need to find the marginal revenue, which is again the derivative we just found, but this time I substitute x with 3, and here you can use your calculator, and the answer will be 41. What does it mean, 41? It is $41 per unit, which means if I sell 31 units, my revenue will increase $41 approximately. And that's exactly what we need to find. Is that really true? If we take R31 minus R30, do we get 41? Which means the revenue after we sell 31 minus the revenue of 30, which is how much the change in the revenue is it exactly 41? Let's see part C. So you need to use your calculator to find R31, R30. Now, how much R31? This is the formula. Just substitute 31 in your calculator. If I did it correctly, it will be 1,315.95 minus 1,075, which is approximately $40.95. That's what we get. Now, 41.95 is the exact increase, which is almost 41 as our prediction or estimation from the marginal derivative. Now the problem is sometimes I'm not able to find exactly R31. I have this formula up to x less than or equal to 30. So the marginal revenue is a very good accurate estimation what will happen next. But sometimes, of course, I can substitute 31. Next question. Suppose the demand function is given by this formula. We need to find the marginal revenue. Of course, first of all, we need to find the revenue itself. I don't have it. The revenue will be number of units times the price, which means x times 160.2x. Now this one will be 160x minus 0.2x squared. And now we can find the marginal derivative from r, which is r prime of x. It will be 160 minus 0.4x. All what we need to do, we need just to write 500 to find the answer. So we just substitute 500 to get the final answer. It will be negative 40. Again, this will be dollar per unit. So if we sell 500 units, and then if we sell 501, my revenue will go down by $40. This is for the revenue. Now we have the same thing for the cost, and just let me remind you of the cost. The cost is we have to add the fixed cost and the variable cost. Remember, in any company, when you produce a product, you have to buy the initial material, you have to buy the electricity, the insurance, the rent. Some of them, regardless of how many products you produce, you have to pay them. And some of them, based on each unit, there is a variable cost. Again, marginal cost, we call it MC, is just the derivative of X. Now, the marginal cost, again, it's an approximation or estimate of the cost from the sale of one additional unit. It is the production, what will happen if we sell an extra unit, how much my cost will go up or will go down. Now, of course, for the cost, it can be zero, it can be positive, and it can be negative. Sometimes the cost, it's so costly to produce a product, and sometimes if you produce one more item, it does not matter because maybe the material is so cheap and the only fixed cost that's already you have to pay it is making the cost high. Sometimes it's positive, which most of the time we should expect a positive cost. But again, it should be always increasing. It should be just when you produce one more item, it means you add some variable cost. It means it has to be even higher. Let's see this question. We have the cost function, and we need to find the marginal cost at x equal to 3. And we need to tell what does it mean. So the first step, I just need to go ahead and find the marginal cost, which is the derivative. It will be 1 over 20x squared plus 4x plus 8. Next step, we substitute 3. And now use your calculator to substitute 3 in the derivative. So the answer will be 20.45 dollar per unit. What this means? It means for any additional production of one more item after 3, which means if we go from 3 items to 4 items, the cost will increase by $20.45. Now, what does it mean if we do 2 additional items? For 2 additional items, the cost will increase by, now if we go from 3 to 4, we will add 20.45. Now if we did another one as an estimation, it will be $40.9. Of course, this is not an accurate, but this will give you an estimation. So the decision maker, the manager, whoever ran the company will have an idea. If we go and produce more items, it will cost me more and my cost will just get up. Finally, we have the profit. The profit is just the revenue, the money I get minus the cost I did, and this is the profit. And it could be positive, it could be negative, it could be 0. And when it's 0, we call it break even, where the revenue, the money I get, is the same the money I spend. Again, marginal profit, it means the derivative, which is an approximation or estimation of the profit if we sell one more item, how much my profit will go up or it will go down. So example number 4, we have it up here. It says that suppose the total revenue of a product is R of X and the total cost is C of X. We need to find the marginal profit. So the first step, we need to find the profit, which will be revenue minus cost. How much is the revenue? Is 50x minus how much cost? You put it between 2 brackets, it will be this one. Now take the minus inside, so you get 1,900 minus x squared. Now if we bring things together, this will be 20x squared. And finally, we just need to find the profit, which is 20 minus 0.02x. This is the profit, the marginal profit. Now, we need to find it at 500 and we compare our answer if we take the difference between 501 minus 500. So if we just find it at 500, we will get $20 per unit. Of course, if we find it by this formula, if we just go ahead and substitute in the original formula, 501 minus 500, this will be just 99 minus 10,600, which will be just 19.99, which is a good approximation of how much we found using the derivative. Remember, in the derivative, we found it $20, which is a very, very good approximation we got here.